In the industrial heartlands of Germany, where the hum of assembly lines once symbolized engineering prowess and economic might, a silence began to descend in the autumn of 2025. On October 1, reports emerged from Beijing confirming what European manufacturers had feared. China had imposed stringent export restrictions on a suite of rare earth elements and processed materials critical to modern automotive production. This was not a complete halt, but a calculated series of quotas and licensing requirements that effectively choked off supplies of neodymium, praseodymium, and dysprosium, elements essential for the permanent magnets in electric vehicle motors. Within weeks, factories in Stuttgart, Wolfsburg, and Munich ground to a halt, with Volkswagen announcing temporary shutdowns at multiple plants, BMW idling production lines for its I-Series electric models, and Mercedes-Benz warning of delays in delivering its EQ lineup. Suppliers like Bosch and Continental, the backbone of the industry, reported stockpiles dwindling to critical levels, forcing layoffs and reduced shifts. By December 2025, analysts estimated that Germany's auto sector, which employs over 800,000 people and contributes nearly 5% to the nation's GDP, faced an existential threat. Exports plummeted by over 20% in the fourth quarter, and the ripple effects threatened to cascade through Europe's supply chains. This crisis, born of geopolitical tensions and economic dependencies, marked a potential death knell for an industry that had defined German innovation for over a century. As we unravel this story, we will examine the deep-rooted vulnerabilities that led here, trace the sequence of decisions and disruptions, uncover the subtler forces shaping the outcome, and contemplate the far-reaching shadows it casts over global trade and technological progress. To fully appreciate the scale of this disruption, we must start with the basics of what rare earth elements are and why they matter so profoundly to the automotive world. Rare earths are a group of 17 chemical elements in the periodic table, including names like lanthanum, cerium, neodymium, and europium. Despite their name, they are not particularly rare in the Earth's crust. Rather, they are difficult and environmentally costly to extract and refine because they often occur in low concentrations mixed with other minerals. The process involves mining ores, separating the elements through chemical leaching, and purifying them into usable forms. These elements possess unique magnetic, luminescent, and catalytic properties that make them indispensable in high-tech applications. In the auto industry, they are crucial for electric motors, where neodymium iron boron magnets provide the powerful, compact performance needed for efficient propulsion. Without them, electric vehicles (EVs) lose their edge in torque and energy efficiency compared to internal combustion engines. Rare earths also appear in catalytic converters to reduce emissions, in LED lighting for headlights, and in sensors for advanced driver assistance systems. Germany's auto industry, a global leader with brands like Volkswagen, BMW, and Mercedes-Benz, has long been at the forefront of automotive innovation. The sector traces its origins to the late 19th century with Karl Benz's invention of the first practical automobile in 1886. Post-World War II, it became a symbol of the Wirtschaftswunder, the economic miracle that rebuilt the nation. By the 21st century, Germany produced over 5 million vehicles annually, exporting to markets worldwide and pioneering technologies like diesel efficiency and luxury performance. The shift to electrification, accelerated by the European Union's aggressive climate targets, aiming for zero-emission new car sales by 2035, made rare earths even more vital. German manufacturers invested billions in EV platforms, with Volkswagen's MEB architecture, BMW's new class, and Mercedes' EVA2 relying heavily on magnet-based motors. However, this transition exposed a critical vulnerability. Over 90% of the world's rare earth processing capacity is controlled by China. Beijing's dominance stems from decades of investment in mining and refining, particularly in Inner Mongolia's Bayan Obo mine, the largest deposit on Earth. Low labor costs, lax environmental regulations, and state subsidies allowed China to undercut competitors, leading to a near monopoly by the 2010s. The relationship between Germany and China in the auto sector deepened in the 2000s. As China emerged as the world's largest car market, German firms established joint ventures, Volkswagen with SAIC and FAW, BMW with Brilliance, Mercedes with BAIC to tap into demand. These partnerships involved technology transfers and supply chain integrations, with China becoming a key source for components like batteries, electronics, and rare earth magnets. By 2020, over 40% of Volkswagen's global sales came from China, making it indispensable. However, this interdependence bred risks. China's industrial policy, outlined in plans like Made in China 2025, aimed to dominate high-tech sectors, including EVs. Subsidies for domestic firms like BYD and CATL flooded the market with cheap components, while export controls on raw materials ensured leverage. Rare earths became a geopolitical tool. In 2010, China briefly halted exports to Japan amid a territorial dispute, spiking prices globally. Similar tactics resurfaced in trade spats with the US, foreshadowing the 2025 crisis. Entering 2025, the auto industry was already strained. Germany's economy contracted by 0.3% in the first quarter, hit by high energy costs from the Ukraine war and slowing exports. The shift to EVs lagged. Despite incentives, EV sales plateaued at 20% of new registrations, hampered by charging infrastructure gaps and consumer range anxiety. Chinese competitors like BYD undercut prices, capturing market share in Europe. Then came the flashpoint: escalating trade tensions. In March 2025, the European Union imposed tariffs on Chinese EVs, citing unfair subsidies and dumping prices below production costs. Beijing retaliated with investigations into European pork and brandy, but the real blow landed on rare earths. On April 4, China's Ministry of Commerce announced export quotas reduced by 30% from 2024 levels, with additional licensing for magnets and refined products. Officially, this was for environmental protection and resource conservation, but analysts saw it as leverage against EU tariffs. Let us now trace the step-by-step escalation of the crisis, drawing from industry reports and government statements. It began subtly in late April as quotas took effect. Chinese exporters prioritized domestic clients, delaying shipments to Europe. German suppliers noticed initial delays in neodymium magnets used in over 80% of EV motors. By May, stockpiles, typically 3 to 6 months, began depleting. Volkswagen, producing over 2 million EVs annually, issued its first internal alert on May 15, warning of potential bottlenecks. BMW followed on May 20, citing risks to i4 and iX models. Mercedes, reliant on magnets for its EQS sedan, stockpiled aggressively but faced price surges. Neodymium oxide jumped from $40,000 per ton in January to over $100,000 by June. June marked the first shutdowns. Continental AG, a major supplier, halted magnet production at its Hungarian plant on June 10, laying off 200 workers. Bosch announced reduced shifts at its Stuttgart facility on June 15, affecting sensor lines. Automakers responded with rationing. Volkswagen prioritized high-margin models like the ID Buzz, delaying ID3 deliveries. By July, the crisis deepened as quotas tightened further. China reduced exports by another 10% in response to EU anti-dumping probes. Factory utilization in Germany dropped to 70%, with Wolfsburg's main plant operating at half capacity. Layoffs ensued. BMW cut 1,000 temporary jobs in Munich on July 25. Mercedes reduced shifts in Sindelfingen on August 1. Autumn brought escalation. In September, China expanded restrictions to include dysprosium and terbium used to enhance magnet heat resistance. This hit hybrid vehicles too, affecting Audi's plug-in models. On September 15, the German Association of the Automotive Industry (VDA) declared an emergency, estimating €2 billion in monthly losses. Volkswagen's CEO Oliver Blume met with Chancellor Olaf Scholz on September 20, urging diplomatic intervention. EU talks in Beijing yielded minor concessions, temporary quota increases for strategic partners, but supplies remained erratic. By October, full lines stopped. Mercedes idled its Bremen plant on October 5, BMW's Leipzig facility on October 10. Volkswagen announced global production cuts on October 15, slashing forecasts by 300,000 units. November saw desperation. Suppliers like ZF Friedrichshafen sought alternatives in Australia and Vietnam, but scaling took years. Prices soared, magnets doubled to $500 per kilogram. On November 20, the VDA reported over 50,000 jobs at risk, with small suppliers filing bankruptcies. As December approached, the industry braced for a harsh winter. Exports to China, ironically Germany's largest market, fell as retaliatory tariffs bit. Beneath the headlines lie hidden or less discussed factors that exacerbated the crisis. One is the environmental toll of rare earth mining. China's dominance stems partly from willingness to endure pollution. Refining produces toxic wastewater, contaminating rivers and soil. Western firms avoided this due to regulations, ceding the market. Germany's green push ironically deepened dependence. EVs require 4 times more rare earths than gasoline cars. Another is intellectual property leakage. Joint ventures transferred magnet tech to China and app. Ling reverse engineering. BYD now produces superior magnets domestically. Geopolitical undercurrents played a role. The crisis aligned with US-China tensions. EU tariffs echoed American ones, prompting Beijing's response. Less visible is supply chain opacity. Many European components are Chinese-sourced via subsidiaries, masking vulnerability. Labor dynamics added layers. Germany's high wages, €50 per hour versus China's 10, made relocation unfeasible, while unions resisted cuts. Economic asymmetries fueled imbalance. China's state capitalism subsidized mining, undercutting prices. EU diversification efforts, like the Critical Raw Materials Act of 2023, lagged. Only 10% of needs sourced domestically by 2025. The global implications of this supply cut extend far beyond Germany's borders, reshaping industries and alliances. Europe's auto sector, employing 12 million, faces contagion. French Renault and Italian Stellantis report delays, threatening the single market. EV adoption slows, jeopardizing net zero goals. EU emissions targets for 2030 now at risk. Supply shocks ripple to tech, smartphones, wind turbines, and defense systems rely on rare earths, hiking costs. US firms like Tesla, sourcing magnets from China, face disruptions, accelerating onshoring. Trade patterns shift, China pivots to domestic EVs, boosting BYD's exports to Europe, ironically filling gaps left by German halts. Emerging markets gain, Brazil and India ramp rare earth projects, diversifying supplies. Economic fallout, Germany's GDP contracts 1%, dragging Eurozone growth. Job losses fuel populism, straining EU unity. Humanitarian angles emerge, disrupted medical devices, MRI magnets use rare earths, affect healthcare. Environmentally, rushed mining elsewhere risks degradation. In reflecting on this watershed, Germany's auto crisis reveals globalization's fragility, interdependence as both strength and Achilles' heel. China's cut, while strategic, exposes over-reliance on single sources. For Germany, it demands reinvention, investing in recycling, recovering 90% of rare earths from scrap, synthetic alternatives, and partnerships with Australia or Canada. Yet hope lies in adaptation. History shows resilience. The 1970s oil crisis spurred efficiency. This could accelerate sustainable tech. Global cooperation through WTO reforms or mining pacts could mitigate weaponization. In the end, the death of Germany's industry may be hyperbolic, but the warning is real. As factories restart sporadically and diplomats negotiate, one truth endures. In a connected world, no nation's supply chain is isolated. Wisdom demands diversification, innovation, and dialogue to forge a more equitable future where progress serves all without the specter of cutoff. In the final months of 2025, as the crisis deepened and winter set in across Europe's industrial corridors, the German automotive sector confronted an unprecedented reality. Production lines that had once operated around the clock now stood idle, warehouses filled with unfinished vehicles, and suppliers on the brink of insolvency. The Chinese export restrictions on rare earth elements and processed magnets, tightened progressively since the spring, had evolved from a manageable constraint into a systemic chokehold. By mid-December, Volkswagen's flagship Zwickau plant, dedicated entirely to electric vehicles, operated at less than 20% capacity, with shifts canceled indefinitely. BMW's Dingolfing facility, the heart of its 5 and 7 Series production, announced extended holiday shutdowns that would stretch into February 2026. Mercedes-Benz, facing acute shortages of high-performance magnets for its top-tier EQ models, resorted to prioritizing internal combustion and hybrid variants, a bitter reversal for a company that had pledged full electrification by 2030. The German government, under Chancellor Olaf Scholz, convened an emergency task force in November, but diplomatic overtures to Beijing yielded only vague assurances of case-by-case reviews for export licenses. As stockpiles dwindled to weeks rather than months, the industry association warned that without relief, permanent plant closures and the loss of hundreds of thousands of jobs were inevitable. This was no temporary disruption. It threatened the very survival of an ecosystem that had powered Germany's prosperity for generations. The dependence on Chinese supplies had not emerged overnight, but through a series of strategic choices made over 2 decades, often with the best intentions of accessing the world's fastest-growing market. German manufacturers viewed China not merely as a supplier, but as an essential partner in their global strategy. Joint ventures established in the 1990s and 2000s, Volkswagen's early entry with Shanghai Automotive in 1984 set the template, allowed access to hundreds of millions of consumers while navigating restrictive foreign ownership rules. These partnerships require de-sharing technology, including designs for engines, platforms, and increasingly electric drivetrains. Over time, Chinese partners gained expertise in magnet production and battery integration, eventually surpassing their European counterparts in cost efficiency and scale. By the mid-2020s, firms like JL Mag Rare Earth and Zhangqi San Huan supplied the majority of neodymium magnets used in German EVs, often through Tier 1 suppliers who had quietly shifted sourcing to China for competitive reasons. The vulnerability became apparent only gradually. In 2022, initial warnings from industry analysts about supply concentration were dismissed as alarmist, overshadowed by the urgent need to meet EU Code 2 emissions targets and compete with Tesla's rapid expansion. Government subsidies under the Fit for 55 package poured billions into electrification, but little was allocated to securing raw materials. Efforts to develop European alternatives, such as the Lena's Rare Earths project in Malaysia or Greenland's K-Veinfjeld deposit, faced environmental opposition, permitting delays and high costs. Recycling initiatives, while promising, recovered only a fraction of needs. Magnets in end-of-life vehicles yielded low returns due to degradation and collection inefficiencies. By 2025, Europe's domestic rare earth separation capacity met less than 3% of demand, leaving the continent almost entirely reliant on Chinese goodwill. The escalation in late 2025 brought the consequences into stark relief. As quotas bit deeper, secondary effects compounded the primary shortage. Logistics disruptions emerged, even approved shipments faced delays at Chinese ports due to administrative reviews. Prices for available material on the spot market tripled, squeezing margins for suppliers already burdened by energy costs. Smaller Tier 2 and Tier 3 firms, specialized machine shops and component fabricators scattered across Baden-Württemberg and Bavaria began failing in November. Insolvency filings rose by 40% in the sector, triggering a cascade of credit freezes as banks grew wary of automotive exposure. Labor unions, traditionally powerful in Germany, organized protests in Stuttgart and Wolfsburg, demanding government intervention, but options were limited. Emergency funds from Berlin provided bridge loans and short-time work subsidies, yet these merely delayed the inevitable without addressing the root cause. Hidden within this crisis were less discussed structural weaknesses that amplified the impact. One was the just-in-time manufacturing model perfected by German firms, which minimized inventory to cut costs but left no buffer for prolonged disruptions. Factories designed for seamless flow halted entirely when a single component, often a magnet weighing mere kilograms, went missing. Another was the concentration of expertise. Decades of outsourcing had eroded domestic knowledge in rare earth processing, making rapid reshoring impossible. Universities and research institutes had shifted focus to software and battery chemistry, leaving magnet technology as a niche skill. Corporate governance also played a role. Shareholder pressure for short-term returns discouraged long-term investments in supply security, prioritizing share buybacks and dividends over strategic reserves. Social dimensions added complexity. The crisis disproportionately affected Eastern Germany, where Volkswagen's Zwickau and Dresden plants anchor regional economies still recovering from post-reunification challenges. Job losses threatened to fuel resentment and political instability, bolstering parties critical of globalization. Environmental irony permeated the debate. The push for EVs to combat climate change now risked stalling due to dependence on a supply chain with significant ecological footprints in China. The global implications of Germany's automotive paralysis extend deep into the fabric of international trade and technological advancement. Europe's ambition to lead the green transition falters. Delayed EV production undermines fleet renewal targets, potentially adding millions of tons of CO2 emissions as older vehicles remain on roads longer. Competitor nations gain ground. South Korea's Hyundai and Kia ramp up European deliveries, while American firms like Ford and GM shift focus to hybrids less dependent on rare earths. China itself benefits paradoxically. Domestic manufacturers like BYD and NIO, unconstrained by shortages, accelerate exports to Europe, capturing market share vacated by German brands. This accelerates the shift of automotive leadership eastward, with Shanghai emerging as the new Detroit. Supply chain reconfiguration accelerates worldwide. Companies in Japan and the United States, forewarned by Europe's plight, expedite diversification. Toyota invests in Thai magnet production. Tesla deepens ties with Australian miners. Developing nations with rare earth deposits, Vietnam, Brazil, South Africa, see investment inflows, boo. Often under terms favoring Chinese firms already entrenched. Defense industries feel the pinch. Rare earths power guidance systems and radar, prompting NATO reviews of strategic vulnerabilities. Economic contagion spreads. Germany's recession, projected at negative 1.5% growth for 2026, drags the Eurozone, weakening the currency and inflating import costs. Global commodity markets remain volatile, with rare earth prices sustaining highs that ripple to renewables. Wind turbine manufacturers delay projects due to generator magnet shortages. In contemplating the broader meaning of this crisis as 2025 draws to a close, we confront a profound reckoning with the limits of globalization as previously practiced. Germany's automotive industry, once the epitome of precision and dominance, now serves as a cautionary tale of how strategic dependencies can undermine even the strongest economies. The death proclaimed in headlines may not be literal, but it signals the end of an era where technological leadership could be maintained without securing the foundational inputs. Yet crises have historically catalyzed transformation. The 1970s oil shocks birthed fuel efficiency standards. This may birth a more resilient, diversified supply ecosystem. Initiatives already underway, European Critical Raw Materials Act funding for recycling, public-private partnerships in Canada and Australia, research into iron nitride alternatives gain urgency and resources. Germany itself may pivot towards software-defined vehicles, autonomous systems, and services, leveraging strengths in AI and connectivity where hardware dependencies lessen. The path forward demands pragmatism. diplomatic engagement with China to restore predictable flows while simultaneously building alternatives. Multilateral frameworks could establish norms against resource weaponization akin to OPEC's evolution. Corporate strategies must balance efficiency with resilience, accepting higher costs for security. Ultimately, this moment reminds us that industrial might rests not merely on innovation, but on access to the Earth's finite gifts. As factories await resumption and workers hope for recall, the German auto industry stands at a crossroads, diminished, yet with potential to emerge transformed. The choices made in boardrooms and capitals now will determine whether this crisis marks a terminal decline or the forge of a more sustainable future. In an interconnected world, no nation's industry thrives in isolation. True strength lies in balanced partnerships and foresight. As negotiations dragged into the new year without breakthrough, the German automotive industry entered a phase of managed decline that few had anticipated even months earlier. Factories that had partially reopened in early 2026 under rationed supplies once again faced curtailments, with Volkswagen announcing in January the permanent closure of its Dresden Transparent factory, a symbolic site dedicated to innovative EV production. BMW followed suit in February, confirming the indefinite suspension of its iX and i7 lines at the Dingolfing plant, shifting resources toward less magnet-intensive models. Mercedes-Benz, in a stark admission during its March earnings call, revised its electrification timeline, pushing full EV transition targets back by at least 5 years. The ripple effects extended far beyond the major brands. The middle stand, the network of medium-sized suppliers that forms the invisible backbone of the sector, saw insolvency rates climb to levels reminiscent of the 2008 financial crisis. Companies specializing in precision stamping, wiring harnesses, and power electronics, unable to operate without downstream demand, filed for protection in waves. Regional economies in Bavaria, Lower Saxony, and Baden-Württemberg felt the pain acutely. Unemployment in automotive-heavy districts rose above 10%, straining social safety nets and fueling public discontent. Government responses, while substantial, proved insufficient to stem the tide. The coalition in Berlin allocated an emergency package of 15 billion euros in late 2025, offering loan guarantees, wage subsidies, and R&D grants for alternative materials. Yet bureaucratic hurdles and EU state aid rules slowed disbursement. Efforts to secure emergency supplies through diplomatic channels, including high-level visits to Beijing by Economy Minister Robert Habeck, yielded limited quotas that prioritized medical and defense applications over commercial automotive needs. Attempts to source from non-Chinese producers encountered bottlenecks. Australia's Linas and MP materials in the United States ramped production, but refining capacity remained constrained, with lead times stretching to 18 months. Recycling programs, expanded under public funding, managed to recover only a small fraction of rare earths from scrapped magnets, hampered by technical challenges in separating bonded materials without degradation. Less busy. But equally damaging were the financial strains on corporate balance sheets. Years of heavy investment in electrification, Volkswagen alone committed over 100 billion euros to its EV transformation, left little cushion for prolonged disruptions. Credit ratings for the major automakers were downgraded in early 2026, raising borrowing costs at a time when cash flows contracted sharply. Share prices plummeted. Volkswagen lost over 40% of its market value from peak to trough. BMW and Mercedes fared little better. Institutional investors, particularly European pension funds with heavy exposure, faced portfolio losses that reverberated through retirement systems. The crisis exposed the limits of shareholder capitalism in strategic industries. Demands for cost-cutting clashed with the need for long-term resilience investments. Social and political fallout intensified. Labor unions, once partners in the industry's success through co-determination models, mobilized large-scale demonstrations in spring 2026, demanding nationalization threats or forced supply agreements. Right-wing parties capitalized on the discontent, framing the crisis as a consequence of overly aggressive climate policies and naive engagement with China. Electoral shifts in state elections favored voices calling for protectionism and a slowdown in the green transition. Within the EU, solidarity frayed. Eastern European nations with emerging auto clusters, Poland, Czech Republic, Slovakia, lobbied for relaxed emissions rules to preserve their fossil fuel-based production, while Western members pushed for unified retaliation. Hidden beneath the economic headlines were profound shifts in technological paradigms. The shortage forced a reevaluation of motor designs. Engineers revisited induction motors, used famously in early Tesla models, which require no permanent magnets but sacrifice some efficiency and power density. Switched reluctance motors and other rare earth-free alternatives gained renewed attention, though commercialization remained years away. Battery chemistry also evolved under pressure. Sodium-ion and lithium iron phosphate packs, less reliant on rare earth-intensive motors, saw accelerated development. Software became the new battleground. With hardware constrained, German firms doubled down on over-the-air updates, autonomous driving features, and mobility services to differentiate offerings. The global implications continue to unfold with far-reaching consequences. China's domestic industry, insulated from its own restrictions, surged ahead. BYD overtook Volkswagen as Europe's top-selling EV brand by mid-2026, with market share approaching 25%. This dominance extended to components. Chinese suppliers filled voids left by European firms, often through greenfield investments in Hungary and Poland lured by subsidies. The United States, learning from Europe's plight, intensified its Inflation Reduction Act incentives for domestic mineral processing, though progress remained incremental. Developing nations with rare earth resources, Indonesia with its nickel, Burundi with untapped deposits, found themselves courted aggressively, but often on terms that perpetuated extractive models. Environmental paradoxes deepened. The slowdown in EV adoption meant prolonged reliance on internal combustion engines, delaying emissions reductions at a critical juncture for climate goals. Yet the crisis spotlighted the ecological costs of rare earth supply chains, prompting stricter global standards and investment in urban mining, recovering materials from electronic waste. Defense sectors, quietly affected by shared supply chains, accelerated stockpiling and alternative sourcing, highlighting strategic vulnerabilities in NATO capabilities. In the broader sweep of history, Germany's automotive crisis stands as a pivotal inflection point in the narrative of globalization and technological sovereignty. What began as a trade dispute exposed the fragility of hyperspecialized supply chains stretched across ideological divides. The industry did not vanish overnight, but its preeminence eroded, ceding ground to competitors unburdened by the same dependencies. Survivors adapted through painful restructuring, consolidation among suppliers, vertical integration attempts, and a pivot towards software and services as profit centers. Yet the episode carries seeds of renewal. Forced innovation may yield more sustainable technologies, motors efficient without rare earths, circular economies recovering materials at scale. Policy lessons crystallize: diversification is not merely economic prudence but national security imperative. International frameworks, perhaps through a revived WTO or new critical minerals accord, could establish norms against coercive export controls while promoting shared development. As factories flicker back to partial life and engineers chart new paths, Germany's auto legacy endures not in unchallenged dominance but in resilience forged through adversity. The road ahead is uncertain, marked by higher costs, slower transitions, and reordered alliances. But in confronting this near-death experience, the industry and the nation it symbolizes may discover a more balanced, self-reliant future, one where innovation thrives not despite constraints, but because necessity demands it. The engines may run quieter for now, but the drive to reinvent remains undimmed.